Hi everyone, and welcome in this episode 14 of the Git series, the series where we try to implement Git in Scala. In the last two episodes, we start to explore the Git index file and what was inside it. And what it is really is, you can see this schema here is sums it up. So you have your working directory, and when you run the command git add, it actually updates the index, and then you can commit the index in the commit history. That's what allows basically to stage the files. So today we are going to look at productionizing the code. Last time we in the episode 12 we read the Git file, and then in the last episode we created some case classes to try to structure it. Now I want to take it a step further and actually productionize it and make it available for the rest of the code. The ambition then will be to implement. So we have a few functions after this episode that I like to implement. We have the update index and the write tree. So the update index here would be basically to update this file that we're going to do later on, and maybe next time what we're going to do is the write tree. That is going to take what's inside the index and write it as a Git tree file in the Git object repository. But to do that, we need to be able to read the index, and that's hopefully what we're going to be able to do today. So I've created this test here that it was really to try to do a first exploration of the index file, because it's a bit complicated. I'm not used to working with codec and binary format directly like that. And you can see that we have a few case class, and we are defining here our codec to encode and decode from the binary format. And we are just having a dummy assertion here. So you can see here that we have this successful decode result of first we have the headers with the version 2, the one entry, and then we have the entry that we passed. The thing that we are organizing the most here is the readme. I'm not too sure about the other parameters yet. So we're going to try to work with that. And what I like to do, what I like to start by is to actually think about what we will need for in the next episodes to be able to read this index. And I think it's fair to say that the index is storing things, so it can be a repository. So I'm going to create here the Scala class index repository. This Scala class is going to be in the same fashion than the object repository. So it's basically a trait. We are going to have the function read index. This read index is going to return us, it could be the index, but it's more likely here to be ZIO of any throwable index. So this is the first thing. First step here, the throwable here is not ideal to track the errors. So what I'm going to do is actually create a specific case class that is gonna wrap the index repository errors so we can identify faster the error. So case class index repository error. I'm gonna just put that for the moment and see where it leads us. And there is the index as well. So the index is something that we didn't yet created. So we can create it later on. We're gonna create it later on. So now we have this index repository here, and yeah, it's important to realize that I put the index repository in the domain because it's business logic related stuff. But the implementation is going to be in the infrastructure. The implementation is specific to the file system. But you can imagine that this software can run in a different type of environment where the index can actually be a database or a key value store, something like that. So I am going to create a package here for I'm going to create a package here for the index and create the implementation. Index repository file system. Okay. This is going to be an object. We are in Zio, so we are working with layers. And it's going to be val live equals new index repository file system. We can implement it's not sorry, it's new index repository, and if you want to import it, okay, import it, and then we can implement. No, I don't want to avoid, I want to implement the read index. Okay, and we can stop here actually because we are going to try to not write code if it's not covered by tests. Okay, so we kind of started one way. Now we are going to go start again the other way. And I'm going to open this test here. And we can see that the concept of index is not quite yet there for the moment. We're using a tuple. This header codec here returns a tuple containing the headers and the entry. So I'd like to introduce this case class of index. Now, what information do we really need here? We need the version for sure, and the version is an int. And we have the entries, which is a list of entries. For the rest, we don't really care because the number of entries is embedded in the list of entries. So that's pretty enough. The version of as an int is probably, we could probably find a better type, like having an enum or something like that. We're gonna keep it like that for the moment. What I'm going to do now is transform that so it can accept my can transform to index, and I'm going to use the X map here, I think, that defines the two functions that can map from the index from a case class and back. So the first is going to be a case class. The first is going to be I'm going to be matching what I have here. So to help us, I can. So here was the type is supposed to look like. Now there is an optimization that I can do here. You can see that the header signature is not really required. So if I do that, what's going to happen is that it's just going to drop it. So yeah, we don't really care about the header signature. So we can remove this here. And we should be left with the version here, the number of entries that we don't really care about, right? And the entry. And then we can create the index from these two values. So this entry class is defined. So if I regenerate, the code, the type here, any, okay. Yeah, this thing for typing is very annoying, so okay. Is it still any here? Okay. Codec of index. Now I've noticed something with IntelliJ. It doesn't actually work very well. What I mean is that sometimes it's highlighting red, but it's actually not the case. So we need to compile. Oh no, it's not what I want to do actually. It's to remove the watch. We need to compile to be sure. Okay. Connection refused. Okay. Not found type indexed. Fair enough. So the first thing that we can do is actually to move the case classes now to unlock from this situation. I'm going to move those case classes into the model. I'm going to create a new class in the package index. And it's going to be index. We have also can I just create? Okay, no, I can't. We have also another class called flags, and we have also another class called entry. Okay, now let's copy those class over here. No, oops. So this one is the entry one. Okay. The flags is now missing. And the flags go to flags. Okay. So so everything should compile here. Okay. So now if I go back to my index repository where the index was not found, now we can import it. Let's try to compile again. Okay, so I can see that the type was not generated correctly for the index repository file system. Should be index here. Oops, no. Import git index. Let's try to see if it works now. Okay, so now it's the test that is not finding the right import. Import class. And we can just import everything from there. And should compile now, hopefully. Okay. So what we have here is a single entry for the moment. We need to implement that for several entries later on. So I'm going to actually create a list, a singleton list. The version is found a long and required an int, so we can actually put long here, even though it's not required. Okay, same result than before. Quite happy about it. Let's create the branch for the episode 14. Episode. Nice. And lazy git. Okay, I'm happy with that, 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 and extract case classes. Okay. It's always good to commit when we are in the in each step that works of refactoring. Otherwise, you might lose all what you have. So now we can just go ahead and continue the refactoring. Now we can see that we have only the encode part that is implemented. We put like non-implemented here for the no, we only have the decoding part. We don't have the encoding part. So what we can try to do is one test that I would like to have is to be able to compare if we can encode and decode and have the same result. So one thing that we can do to do that, so you've noticed here that we have we didn't consume all the bytes of the index file. We just consumed the first bits because then there are extensions that I believe we are not interested in yet. And that's the 168 bytes is actually the leftover. And if I divide by 8, that's 21 bits. 21 bytes, sorry. So what I'm going to do, actually I can print file bytes length minus 21, and that should give us the number of bytes that we want for to test the decoding and encoding. So it's 83, right? Take 83 bytes and headers and entry. Okay, so that's the first bytes of the file, and we can only use those. What we're gonna do now is say that the headers and entry should equal the value that we're gonna return here. So equal what? Equal to result. Not very inspired here. And the result is the value that we're gonna return here. So here you can see that we are just decoding. So let's decode and then encode. So this decode function returns an attempt. So that means that an attempt is kind of an either. If we look here, so we have this filtrate, and then we have the object. I think is class. Okay, we have the successful and failure here. So what we're gonna do is decode first. So header codec is gonna be decoded. Sorry, decoded is gonna be header codec dot decode of yeah, that's what it's, sorry, headers and entry to array. So it's already an array of bytes, so we don't need that. And we don't want to yield decoded, but we want to encode again. Re-encode it. Re-encode it, and it's going to be header codec encode decoded value. Re-encode it. Yeah. Re-encode it. Okay. So what is that returning us? An attempt of bit vector. What I'm gonna do is, do I have value or required here? Oh yeah, this is the re-encoded. Yeah, so this here we're gonna have, no, I want the type. So it's an attempt of a bit vector. And I am actually going to containerize the type here and return just an array of bytes. Okay. So now the test should actually pass. Obviously there is it's not implemented correctly. This decoded part probably works, but not the re-encoded part. So let's take a look. Okay, we have the index. I believe here that we can we have the index deconstructed without the case? I'm not sure with Scala 3. So Copilot is suggesting version entry, which is correct, and then it's returning version entry size, entry head. Yeah, that sounds correct. Yeah, it looks like he's not finding the entry, so maybe we need a case. Okay, good. This one is done. Why that's so weird. Yes, in the plugin, the Scala plugin might not be completely perfect. For the flags, let's do the flags. For the flags, so we need to transform it from the flags object to the tuple, right? Yeah, that's an option. I'm happy with that. Just gonna rename that to flags. Is this compiling? Okay, compiling, but not still unimplemented. And we have the entry to do. So the entry was a bit complicated because we needed to pass all the fields, and then from one field, from one of the flags that contains the name of the length of the name here, we need to read the pass name. So here we have a function from string to entry. So here we just need to extract the path in entry, right? So if I do entry pass, is it not supposed to be entry? Entry pass, okay. I assume that it's IntelliJ that is not working. Oh, name. Okay. Yeah, the compiler was suggesting it. Do you mean name? Okay, nice. So this part here is done. Yeah, this is a bit messy here. I'm not liking that too much. Maybe there is a way to improve that. Anyway. And the consume, so to consume we can return from the tuples from the entry to the tuples. So what I'm going to do here is I'm going to create a block case entry. Oh, so what is it giving us? Okay, that looks not too bad approximately. The only difference is that there might not be the name here, because the name was already taken care of before. Let's try to compile to see. Okay, so here we can see that we have a difference, and the difference is actually that there is one that is a type chunk and the other of an array. So to array, but hopefully, okay. So we can see that the test is passing. Now it's good to have a bit of confidence by changing the parameter around. So for instance, if I try to exchange the GUI ID and UID, it should fail. And it does fail, okay. So our test does do something. Does test something. Okay, I am happy with that. The test is passing. Let's compile. Let's commit, sorry. Implement the encoding logic.